The full name of this course is Global Environment and the Evolution of Human Culture. Now, our focus on human culture so far has probably not been in the way that you are used to thinking about culture. What is it that is culture? Yes?
It's a way of life.
Way of life. It's what people do. Now, that's good, a way of life. I like that. So, we have been focusing really on culture in terms of how do people make their living. They make their living from hunting and gathering, or from agriculture, or from, in our case, from industrial, the whole complex industrial system. And so we have been talking about culture in the ways that humans have used energy to exploit the natural environment and to generate sufficient wealth. By wealth, we don't mean super wealth. We mean simply the ability to eat and have a place to stay and be clothed and your basic requirements of life. But of course, there's another dimension of culture as well. And culture is a way of life, what people do. And it's often expressed in their music, in their dance, in their plays, in their myths, in their storytelling, in their literature. All kinds of things are an important part of culture. But another thing is that many of the environmental problems of the world, as we will talk about later in this class, are urban problems, are issues related to the city. So we worked with a group, anybody ever hear of Christadora? That brings city kids and takes them into the field for the summer. And very often this is when the kids find out that they're really, really interested in environmental issues. Some of them, of course, want to get out of the city, while some of them want to come back and make the city a more livable environment. My own feeling is that we don't have a chance of solving our environmental problems unless we can solve our city problems. Because if you concentrate people in the city, they have less impact than if you spread them all over the landscape. That's something we don't know well enough, but it's probably a generality. You don't solve the world's environmental problems by going off in your little cabin in the woods. You solve the world's environmental problems by rolling up your sleeves and dealing with the problems where the problems are. Let's not forget that while all of this resource exploitation and people killing each other and all this stuff is going on, here and there, these lights blink on of wonderful cultural things taking place. And I hope some of you, many of you, will take advantage of that. Okay, back to the main part of this course. How come Costa Rica has tremendous standards of health, of literacy, of all the basic aspects of life, and they're basically very happy people in a region where lots of times people are at war and not happy and are starving? How do they pull that off with the problems they have of agriculture, where we showed in the tropics you cannot have really high yield per hectare? And I think the issue comes down to fundamentally one thing: their government works. They pay a quarter or a third of their money to government taxes. Corruption is very low. It's a properly functioning democracy, in part because the country is so small it's hard to steal. And because they have safeguards put in there. You have to have safeguards all of the time. These bastards from Enron were out there trying to get the regulators out of the picture, right? And look what happened. They basically stole all the money of their own employees, let alone all kinds of other people, to maintain their high lifestyles. And they were in there arguing that government shouldn't intervene in business. Well, let me tell you, if you don't have government keeping an eye on what's going on, then people are just going to steal. So in Costa Rica, my answer is government works. I don't argue for big government or small government. I will argue for effective government, and I think we know how to do it. There are other reasons. Their cultures, a culture of hardworking, intelligent people. The agricultural yield is lower than it is here, but it's still not bad. They have a lot of science. They believe in science. They apply science to agriculture. And if their population wasn't growing exponentially, I'd have a sense of a great future for them. But the population growth keeps undermining their progress. And part of what they have, they pay for with debt. Why don't they continue to do shifting cultivation? Because then they don't have to buy fertilizers. They don't become dependent upon the industrial countries. Good question. Anybody know the answer? I might have said it in my talk, but I didn't say it clearly enough. Think Bartlett.
I would think there's just not enough land.
Not enough land for the number of people they have. Shifting cultivation works great if your density of people is low. My feeling is that there's been a turning away from the population issue in many people who think about it. And if you go in and look at it very carefully, you find out that there's population issues are behind most of the problems where development is not working. You had a good question too. Why does Costa Rica export bananas and coffee? A lot of people say that. Why don't they just grow corn and wheat and rice and beans, which is their principal diet, and cows? Why don't they just do that? And the answer is, you can feed about 8 times more people on a hectare of land by growing and exporting coffee and importing wheat with the money. Because coffee is a more valuable crop. That's one answer. The other answer is, that was good. The fundamental thing is that they need to buy fertilizer. And in order to buy fertilizer, you have to sell something that the rest of the world will pay with foreign exchange, with dollars. And you all pay for coffee in bananas, right? With dollars, which eventually, some tiny part of it goes back to Costa Rican farmers, and then they can buy the agriculture, then they can buy the fertilizers and other inputs to run their own food crops. And remember, they can't grow enough corn or rice or beans without fertilizers and pesticides and other agro inputs. Why? Because there's too many people. This Costa Rica example, I think, is really, really important because I think it is an exemplar of most of the rest of the world, or a great deal of the rest of the world. At least half and probably 2/3 of the people in the world are facing this problem. Tremendous increase in agricultural, in number of people, limited new agricultural land, or at least good agricultural land, increased need for imports of agrochemicals to make the agriculture more productive, and a need to get foreign exchange to pay for that. And if they don't, they go into debt. And debt is a really big problem in Costa Rica. It's a huge problem in much of the world. And if I could say to anybody that's from a developing world, number one thing is never borrow a nickel from an industrial country. Only borrow it internally. Who wants to tell me in a short summary what's going on in this graph?
All around 2050, the graphs that we look at, similar to this one, have a peak of population and already peaks of like agricultural output, and already peaks of resources and fossil fuels.
Wait. That's 48 years from now. How do you know? What do you mean? Huh?
Models.
Models? What's a model? It's a guess. It's a guess as to what might be in the future. Do we know this will be true? No. Now, in fact, who thinks it won't be true? Well, I'm going to give you a few quotations. So you all know what's going on. This is a computer model of the future of some basic properties. We're going to come back and talk about it. Okay, I'm a modeler. Is that what I do? No. You saw my model of Costa Rica. Is that a good model? Well, you know, so far it looks okay, but we don't know when it gets well into the future. What is a model, and how do I use models? First of all, I don't use models as God's own truth. I use models as a tool in my tool bag. Now, in this course, we give you 3 definitions of model. First of all, it's a simplification, trying to capture the essence. A model airplane is a model of a real airplane. It's simpler, but it gets the essence. It flies around. Number 2, a model takes a series of pieces of a system that we think we know how they work and puts them together and tries to make a more complex prediction from the behavior of a complicated entity from the behavior of the pieces that we know. The third definition of model, the one that I prefer, is a model is a formalization of our assumptions about a system. A formalization of our assumptions about a system. And what this is saying is that we're making educated guesses. Now, the virtue of a model is that when you formalize your information, you can test it. It allows us to use the scientific method in complex situations. That's the real strength of models. There are other strengths called sensitivity analysis and validation. We don't have to worry about them now. Okay, so let's just take a look. What happens is that food per capita in this model. Look, it starts in 1900. Here we are today and runs to 2100. Now, this was published in 1975. So here is the number of people in the world. This is what they call resources. They don't say exactly what resources is. We'll come back to that. This is food per capita. This is industrial output per capita. And this is pollution. People are dying here because the pollution is so high. That's part of the reason. Are people dying in the world today because of pollution? You bet. You bet, millions of them. Not you and me. Lots of folks in the real polluted parts of the world. Okay. Now, there's a bunch of people, including Mr. Leonard Ross and Peter Purcell, who generated a collection of what we thought were devastating critiques of limits to growth. And you must realize that these are basically well-meaning people. They think it's important not to get in the way of economic and industrial progress because they think it will make poor people poorer. And that's a good question. We see how that's important today. But let's look at some of their arguments. They're not arguing morally here. They're arguing scientifically, or quasi-scientifically. I think the contribution to the MIT team is good, that they attempt to make explicit and quantitative what has been impressionistic and qualitative in the public's mind. But here's where economists, meaning the guys who are speaking, have a violent allergic reaction. It is not that social sciences deny that population, pollution, and resources are important problems. They say they're good problems. They are clearly among the most difficult issues of theory and policy and political economy. It is the approach that they're arguing with, rather than the subject. And he says the underlying assumptions are found in pure fantasy. World Dynamics, that's a publication on this, did not refer to a single scientific study. I think they're right. Good point. We don't have, then one asks them for information. We don't have any data. We didn't do any research really. We just have a theoretical model. Where did they get the model? We just thought about the problem. Well, that's what they said. The thing is that they thought intelligently about the problem, but never mind that. And so forth. We have other comments from them. I'll read one or two more. And do you feel that Limits to Growth, the title of this book, overstates the finite sources of energy without taking into account possible new discoveries? This is 1975. We certainly have no basis for predicting the future. There's a clear possibility that the development of nuclear fusion, remember that one, will open up a vast and perhaps enormously cheap supply of power. Notice they're only interested in cheap. That's the implication of the best studies that have been done today Tobin and Nordhaus at Yale have estimated the production function in modern times, and they find an exponential growth in technology and in the productivity of energy sources. Dr. Hall does not find that at all. Dr. Hall thinks he's been doing more quantitative research on this and finds that the productivity of energy is about constant all across the world. I showed you data on that the last time or two, right? Maybe a slight improvement in the United States, but possibly that's because we dump our heavy industries onto Greece and Mexico and Korea and so forth, so that if you buy a Pontiac, the steel was made in Korea, for example. But anyway, this is a perspective of the economist. Well, let's go back to the fundamental model and look and see whether the model's any good. That model's been running for 25 years. That's enough time, so we should find if it's a bunch of total hooey, we should be able to tell that by now. So, let's take a look at resources. What do you think the most important resources are that we have? Based on what we've talked about in class. Fossil fuel? It's good. That's one candidate, right?
Define important. Define important.
Yeah. So, well, important to human health and well-being. Solar fuel, that's constant, no question there, yep. Water, good. Air, clean air. Soil might be another one. Dr. Pimentel will talk about that on Wednesday. Well, can we start with fossil fuel? And I've told you we got lots and lots of fossil fuel, but let's just talk about the most important fossil fuel, which is oil and gas. And so, in 1975, it indicated that there was lots of it left, right? We'd only used, going down from the top, we'd only used about maybe 15%. Now here we are at 2002, nearly halfway through. Does that sound familiar? What word would spring to your mind, should spring to your mind? What person's name? Hubbard. Now, food per capita. Food per capita has been increasing and flattening off. The model might be a little bit optimistic on that. How about population? So when we started doing this, it was 1975. The world had about 4 billion people there. Now this is indicating that by 2000 it has around 6 billion people. 2002, 6.2 billion people maybe. How's that sound to you? Right smack on the money, right? So far, 3 for 3. Okay, industrial output per capita. It shows it's still cranking up. Well, boy, the amount of industrial stuff in the world is certainly bulging on the shelves of the world, right? Whether people can afford it or not, it's certainly there. So, we can't argue with it. And pollution. Well, how about what might be the most important long-term pollutant? Carbon, CO2. I mean, certainly that's going to be a tough one. We're going to have a whole lecture on that later. But let me tell you, this looks a whole lot like the CO2 curve. So, all kinds of people have said the model doesn't work. But I say pretty close to 5 for 5. Pretty close to 5 for 5. At least if you accept my definitions for what we have with the model. The trouble is the model should have done explicitly oil, coal, should have done more explicit things, and no argument there. And it has been done since then, and the results don't change very much. But that's not important now. So 25 years later, I'd like to make the point that the model's still kind of on the money, and we don't know what's going to happen here. There's the possibility that the model is correct. We cannot dismiss it, as these economists have. Now let's just take a look at a little bit of data. I went to China in 1980, and they had just instituted they just instituted a one family, one child policy. That's the most stringent way to control population you can imagine, right? Have a strong, authoritative central government says one family, one child. Well, children went from being abused to spoiled in 10 years. Not all of them, of course. 96, there was 1.2 billion. The birth rate is dropping like the dickens, but there are so many young girls who haven't entered the reproductive age yet, that even with this huge attempt to get on top of the population problem, the population continues to grow. Maybe the problem's a little tougher. Well, let me ask you, you know, they run it with unlimited resources. They do all kinds of things to try to find out how to make an optimistic future. Can anybody tell me what 2 things they have to do to make a future that doesn't go haywire? Like, one thing you have to do is you have to stabilize the population, but they say that's not enough. So they say you have to do 2 things to make a world that makes any sense. You have to, as Dennis says, stabilize the population and stop investments. What's investments? That's what Wall Street's all about. This is such an astonishing conflict with everything that's near and dear to everything that's American, and everything that's probably German and French and Italian and everything else. It's what this whole class has been about, is the evolution of human culture has been about the evolution of investments. Investments in exploiting more and more resources. And these guys say the only way we can make the model work is to stop population growth and stop investments. Think you're going to be able to run for president on that one? I don't know if that's true. The model says it's true. Is the model right? Only so far. Yes?
This would mean absolutely no advances in science, technology, and
No, I don't think it means that. I think we can have advances in becoming much more efficient. Trouble is, when we become more efficient, we just combine that with more growth. It's tough.